making x? The variable x is going to stand for what?
What we do see in college is a lot of students who've been rushing through the earlier preparatory material. They're lacking the foundation that they need in order to succeed in that calculus. They're lacking the skills in algebra, and often they're lacking the kind of expertise that they should have picked up in middle school in grades 6 through 8 in ratios and proportions. I see a lot of calculus students who are still weak in those areas. And yes, they've memorized lots of procedures, but unless you really understand what you're doing and you have that foundation, once you get to that fast pace of college and university mathematics, you're really going to stumble.
So I could pick any points on there, on that line, draw a right triangle, and I'm going to get the same, what's that ratio called? Slope. I'm going to get the same slope. Okay. The algebraic concepts that kids are learning in the Math 8 class are what we used to teach in Algebra 1 and have now taken it to this level where they can get a strong foundation before they enter Algebra 1. We teach equation solving, we teach slope, graphing linear equations.
And what these standards do at the earlier grades is concentrate much deeper treatment to some of the foundational skills, including ratio and proportion relationships, expressions and equations, which help build to the algebra.
It's important for the Common Core to really focus in, or for students to really focus in on those basic skills like working with fractions, basic facts, procedural fluency, decimals, because when they get to me as an 8th grade teacher or beyond, I want them to be fluent.
By the time you get to 7th and 8th grade, a lot there's a whole lot of algebra built into standards, even if you haven't accelerated into a formal Algebra 1 class. And I think, in fact, that for many students, it's going to be outstanding for them to get that strong preparation through not only algebraic thinking in the middle grades up through grade 8, but understanding ratios and proportions and being able to really use proportional reasoning. And I think we have an opportunity, because we've really looked at making strong incorporation of what used to be some high school skills into the middle school. Let's take advantage of that and prepare students well for success in high school.
What I'm teaching in my classroom gets my students prepared for college and career readiness. They're solving the type of problems that they're going to have to solve when they're in the real world, when they're in college, when they're in their career. It's not just going to be simple problems where they're going to be handed a textbook and say, here it is, here's what you're supposed to do. They're going to have to become their own thinkers. And what I'm doing in my classroom is preparing them to do so that they're ready when they leave.
One example that I use with students when we're looking at exponential functions is offering them an amount of money that they would get paid every day and asking them to compare between two options and choose the one that they think would be better before they actually look into the mathematics behind it. So option number 1 might be that I'll pay you a penny today, tomorrow I'll pay you 2 cents, and doubling it each day there forward. The other option would be I'll pay you $100 today and then an additional $100 each day thereafter. And asking students to first just make a choice. Which one would you choose? And most students will go the $100 a day because that sounds great, especially to a middle schooler. But when you actually go in and look at the math that's going on and what's happening in the exponential growth of the other option, students are blown away by how quickly that penny turns into a lot of money.
We're really in a world now where we have a lot of technology that can do the basic computation, and we really need students who are thinkers, who can take the math take the concepts to the next level and now solve a complex problem knowing those math skills. There'll be some technology there to do the computation, but can you think through the problem? Can you reason? Can you take data and interpret it? Can you draw conclusions from the data that you have and make a conjecture and formulate a hypothesis? Can you do those kinds of things? Can you argue your point and justify why you think one solution is better than another? And I always think about engineering because my husband is an engineer, and that's all he does every day. He tackles real world problems.
I think if students can develop understanding of the standard algorithms at the elementary level. They can understand why they multiply multi-digit numbers, for example, the way they do. That understanding will serve them very well when they go off to multiply polynomials as they learn algebra, because they'll recognize that the steps are basically the same. So when we develop good understanding at the elementary level, we give students a fantastic foundation to succeed in algebra.
So what we're trying to do in good, solid algebra instruction is build the conceptual understanding through having students investigate real-world kinds of problems that are accessible to them. And then from those kinds of problems, and solving a large number of those problems, over time, you are going to generalize and pull out the procedures we want them to learn. We're still going to learn the procedures and expect students to become fluent with them, but they'll have some meaning behind why they work.